Ever wonder how they build all this software without having to write every single line of code from scratch?
Yeah.
Well, today on the deep dive, we're going to find out because today we're looking at code libraries and how those are used to build software.
That's right.
Think of them like secret shortcuts.
Yeah.
To build amazing tech, and understanding this stuff can really give you a leg up, whether you actually code yourself or just want to get how this digital world works without feeling totally lost,
Absolutely. And we have a great video to help us with this topic.
Oh, yeah.
It's a YouTube video from the Code Curious channel featuring Mrs. Julie Alleno.
Okay.
It's titled CCSP 314.1 Libraries. And it does a really good job of just kind of laying out these core ideas.
Okay, so our mission today is to really understand how programmers use these ready-made collections of code, which we call libraries,
Right.
and how they use the instructions for using them, which are called ATIs, right?
Yes.
Even if you've never coded before in your life, never typed a semicolon or anything. This is going to really help you understand how pretty much every piece of tech you use actually works. So, are you ready to unpack this superpower?
I'm ready. Let's get into it.
Okay.
So the video starts by reminding us about this fundamental idea of using pre-written procedures.
Okay.
Think of these as like little bundles of code that already know how to do a certain task. Like, for example, they use a move backwards procedure for a robot,
Yep.
which you might remember from some of those past AP Daily videos or maybe the AP exam reference sheet.
Yeah, exactly. So instead of having to code every single tiny movement, like how fast the motors are spinning or what the sensor readings are to go backwards, someone's already done all that work and just packaged it up into this neat little procedure called move backwards.
Exactly.
And then they show in the video how by using this pre-existing code, you can quickly build a whole program to make the robot navigate around a bunch of obstacles, in their example, to get to a gray square, right? It's amazing. The amount of time you save, it's incredible.
Yeah, pretty awesome. And what's cool about it is you're leveraging, somebody else's hard work. You don't have to get bogged down in the really low-level details of how to make the robot take one step back. You can use that as a building block and focus on the bigger problem. How do we get this robot to where it needs to go?
Yeah.
It's a huge efficiency booster and a core reason why these libraries are so useful.
Yeah, for sure. Now, here's where it gets really interesting, though. Imagine you find one of these pre-written procedures,
Okay.
but all you can see is the name of it, like a calc average, and maybe, some information about what it needs to work, right? Like a list of integer grades, the parameters,
Yeah.
So if you see calc average and that it needs a list of grades, is that enough for you to just go ahead and use it in your program? What if it doesn't do what you think it does?
That's a great question. Yeah.
Right. Does it just spit out the average? Does it round up to the nearest whole number? Does it flag you if there's failing grades in the list?
Exactly.
You don't know the full story just from the name and the inputs.
Right.
And that's where documentation comes in.
Exactly.
So the video explains that documentation is like the instruction manual. It tells you exactly what the procedure does.
Right.
So in our example of calc average, the documentation would tell you, okay, it takes a list of grades and it gives you back the average. And that's the key, right?
Yeah.
With good documentation, you can use these procedures really effectively without having to understand all the nitty-gritty code inside.
Exactly.
All you need to know is what to give it and what you're going to get back out of it. And this just speeds up the development process so much.
Oh, absolutely. Yeah.
Because you're not having to reverse engineer someone else's code all the time or rewrite stuff that's already been written.
It's all about working smarter, not harder.
Totally. So we've got these reusable chunks of code, the procedures, we've got this instruction manual, the documentation.
Right.
So now let's zoom out a little bit and look at the bigger picture, right? Libraries and APIs. So a library, as they explain in the video, is just a collection of these reusable procedures. All bundled up into one file. Think of it like
a toolbox.
Yeah, like a toolbox or a workshop.
Yeah.
Full of tools.
Yeah, with all these specialized tools.
Yeah, exactly. And then there's the API, which stands for Application Program Interface.
Right.
Doesn't that sound kind of technical?
It does sound a little bit intimidating.
Yeah, like you need a secret handshake or something.
Exactly. Yeah.
So what is it?
So the video does a great job of breaking it down and demystifying this concept. Basically, the API is the blueprint. It's the set of rules that tell you how the procedures within a library work.
Okay.
And how you, as the programmer, can use them. So it's kind of like a more formal and comprehensive version of that documentation we were just talking about.
Got it.
It's the contract, the terms of engagement between different pieces of software.
Okay, so if we go back to our calc average example, the library is that file that actually has all the code that calculates the average, right?
Right.
And the API is like, hey, if you want to use this calc average thing, here's how you do it. You got to give it a list of numbers
Exactly.
in this format.
Yeah, and you'll get back a single number representing the average.
Exactly, yeah. And what's really cool is that, like, APIs are everywhere.
They are.
The video mentioned how, like, all the big tech companies, social media companies, they all provide APIs so other programmers can build apps that work with their services.
Right.
Like, if you think about, like, apps that can show you restaurants near you on a map, or like social media platforms that let you post from other apps.
Right.
A lot of times, that stuff is all powered by APIs.
It is. Yeah, it really is the glue that holds a lot of these systems together.
Yeah, and even programming languages themselves have APIs.
Exactly.
That define, like, how you use the language. So this is, like, a really big deal. It's not just some abstract idea. It's how a lot of the tech we use works.
Absolutely. It's a fundamental concept in software development.
For sure. Now, they give a really good concrete example in the video that I think anyone who's studied a little computer science is going to recognize: the AP exam reference sheet.
Oh, yeah, that's a great one.
It's like the perfect example of a mini library, right? And documentation all in one.
Exactly. Yeah.
So it's got all these code snippets and structures for basic things like if statements, repeat loops, and procedures, right? But it doesn't just show you the code, it also shows you how it's written and how to use it.
Right.
So it's like a toolkit with all the essential coding elements, plus like the API telling you exactly how to use each tool.
Yeah, I like that. It's a really good way to think about it.
Yeah, like a little mini coding workshop.
Yeah, exactly. Yeah.
Okay, so now they want to like really test your understanding.
Okay.
And see how you apply all this.
Okay.
So they give you a question.
Okay.
It says, which of these procedures would be most helpful if you're writing a program to calculate someone's GPA?
Okay.
And they give you 4 options.
Yeah.
Procedure is equal, which takes 2 positive integers, returns true if they're equal.
Okay.
Procedure count quotient takes 2 positive integers, returns the quotient.
Okay.
Procedure get high grade takes a list of grades, returns the highest grade. Procedure calc status takes a number of credits and returns, like, you know, senior, sophomore, whatever.
Got it. Okay.
So what do you think? What do you need to calculate a GPA?
Okay, so if we think about how we normally calculate GPA, you're going to need the total number of grade points they earned and the total number of credit hours they've taken. And then you're going to divide those. So division is a really important part of this. And if we look at the options, only one of them actually does division. And that's calc quotient.
Exactly.
Takes 2 integers, divides them, gives you back the answer. So even though none of the procedures say calculate GPA, calc quotient is the one that's going to give us that core mathematical operation that we need. So, you know, it's an example of how you might have to get a little creative, right? Look at the tools you have and see how you can use them to solve a specific problem, even if there's not one tool that does exactly what you want.
Yeah, exactly. There might not be a hammer, but you can use the back of the screwdriver, you know?
Exactly. Yeah, that's a good analogy.
Okay, so what are our key takeaways here for our listeners?
So I think one of the most important things is this idea that, you know, crucial skill in building software efficiently is being able to find and use existing code libraries. You don't have to reinvent the wheel every time. There are all these resources out there, all these pre-built tools. And libraries are just a collection of these tools, ready-to-use procedures that can save you so much time and effort. And the API is your instruction manual.
Exactly,
It tells you how to use each of those tools effectively. And I think if you zoom out a bit, understanding these concepts really gives you a better understanding of how software development actually happens. I mean, complex software, it's often built by breaking down these huge problems into smaller, more manageable pieces. And then they're using these well-documented pre-existing chunks of code to build these powerful applications. It's all about efficiency, collaboration, and building upon, the work of others.
Right, because like you said, you don't have to reinvent the wheel.
Exactly.
Yeah. So what does all this mean for the average person, the person who's not going to go out and be a software engineer?
Well, I think even if you're not a coder, understanding these things gives you this really cool insight into how complex technology works. It helps you see that it's not just magic.
Right.
There's a lot of thought and planning and cleverness that goes into it. And it's often, like I said, built using existing tools.
Yeah.
So it's not a black box, it's a process.
Yeah, that's a really good point.
Yeah. And this actually leads to a really interesting thought.
Okay.
I want you to think about all the technology you use on a daily basis, right?
Yeah.
I mean, the apps on your phone, the websites you visit, all the smart devices in your home. How much of that do you think relies on these vast networks of pre-written code libraries and APIs that are all working behind the scenes, right? You don't see them, but they're there.
Right.
They're allowing all these different systems to communicate and function together. It's a truly interconnected digital world.
Yeah. That's pretty wild to think about.
It is, and it's all built on this foundation of reusable code.
Yeah. So next time you're using your favorite app or website, think about all those libraries and APIs working hard behind the scenes. Pretty cool, huh? Thanks for joining us today on The Deep Dive. We'll see you next time.
See you then.
Bye.